Hi everyone, so here we are back to lockdown learning. It's going to be very similar as to what we did before the summer holidays. Okay, so I'll just be uploading wee videos like this. If you can copy this into your notes jotters, and then the good thing is now that you've all got textbooks, so you can use the textbooks for the questions, and I'll also post like a short assignment every week of just mixed questions, and that's the layout that we're going to do that. So if you go back to your notes jotters, what we finished off with in December was integration by parts. Now you need to remember this formula. So it's uv minus the integral of u dash v. Okay, remember I got you all to like highlight this and put it into your formula sheet? You need to know that, okay? And you should know by now we use this formula when we are integrating, and it's kind of like the product rule but for integrating. So if you've got like x times, I don't know, I'm making this up, like sine 2x, right? So remember, you know how you've got the two things here that's multiplied together? This is when you know to use integration by parts. And it's really important which one goes as u and which one goes as v dash. So it's always the one that becomes simpler when you differentiate that you put as u. So obviously x becomes 1 when you differentiate it, so that's what will be u, and then whatever's left is what you integrate as v dash. So that's just a quick reminder of what we did before Christmas, which feels like a lifetime ago for me. I don't know about you guys. Alright, so can you go back to your notes jotters? And your heading is going to be definite integrals. Just trying to get used to writing on this graphics tablet again. It takes a while, so I do apologise for my bad handwriting here. Okay, so definite integrals. Example. Here we go. Right, so we're pretty much doing the exact same thing as before, so it's still integration by parts. The only difference here is that with your integral, you've now got limits, and that's why it's called a definite integral, because you're not going to have plus c at the end of your answer. Okay, so we're going to work out the integral between the limits of 0 and pi over 4. In brackets, so you've got x plus 4, close bracket, sine 2x dx. Okay, so that's your question. If I'm going too fast at any point, feel free to pause the video and go through at your own pace as well. I thought it would be better just continuing making videos instead of doing a live lesson, just so you could always go back and double check the answers or just do it in your own time. Okay, so when you look at this question, straight away you should be thinking, right, this is definitely integration by parts, because you get two things multiplied together here. So think to yourself, right, which one becomes easier when you differentiate it? And it's obviously going to be the x plus 4. So at the side here, I'm going to let u equals x plus 4. And then v dash is whatever's left over, which is your sine 2x. Okay, you know the drill by now. You're going to differentiate this part. So u dash is, so if you differentiate x plus 4, you just get 1. And on this side, we're going to integrate the v dash to get v. So if you integrate sine, that's going to go to negative cos. Oops. So negative cos, still got your 2x in here. And because you're integrating, you divide by the derivative of the bracket there. Okay, so that's what you get if you integrate sine 2x. Okay, now for every single question, I would recommend you write the formula down. Okay, so uv minus the integral of u dash v. Okay, so you actually get 0 marks for writing the formula, but it's a good habit to get into, because if you get the formula wrong, then you're going to lose marks. You do get a mark for doing this part though. Okay, so make sure you do your u and v dash. Okay, so it's pretty much the exact same as before, apart from I'm just going to put big square brackets around everything here, and then I'm not going to touch the limits until the very last line. It's the easiest way to do this. Okay, so here you've got uv, so u is going to be x plus 4, so stick that in brackets. V is going to be your negative cos 2x over 2. Just like this. Okay, so that's your uv done. Take away your integral of u dash v. So u dash is 1, v is going to be this. Now, see if you notice here, I've got minus, and then v is minus cos. So what we would be writing in is this, but I'm going to show you a wee trick here, just to make your life a little bit easier. Now you see how you've got a double negative here? So straight away I'm just going to make that into a plus, and then get rid of that part. Trust me, it's going to make your life so much easier instead of dealing with your minus, and then your minus and your integral as well. Alright. Okay, so that's u, because u dash is 1, and v in here. Okay, this is the exact same as all the previous examples. The new part is I'm going to stick big square brackets around it, and write my limits 0 and pi over 4. Okay, so I'm not going to touch them until the very end. Alright, let's work this out. So this part here, you could simplify this a little bit, or you could keep it the same. It's entirely up to you. And we're just going to integrate this part here. So what I'm going to do to this first part is just to see this minus and then the 2 on your denominator. I'm going to bring that out to the front, so it's negative a half. So you don't need to do this here. Just tidies things up a little bit. Brackets is the same, and here we're just going to cos 2x. Oops, I just wrote x in there, that's for 2x. There we go, cos 2x. Right, and then let's deal with this integral. So if you integrate cos, that just goes to a positive sign. So sine 2x, remember when you're integrating, you divide by the derivative of the bracket. So I'm dividing by 2, I've already got a 2 at the bottom, 2 times 2 gives you 4. Okay, I'm not putting plus c, just going to keep it like this. Alright, so everything that we've done is the exact same apart from those big square brackets. Now all you need to do is sub in the limits and then get your answer, and then you're done. That's it, it's easy as that. Okay, so you do get a mark for showing that you're subbing in limits. So I know it's a pain, but you need to write this next part here. So I'm just going to sub in pi over 4 into everything, so you might want to write quite small in this part. Whatever you see in x, I'm changing for pi over 4. So I've got a 2 here, so it's going to be 2 pi over 4, or you could simplify that to pi over 2. Okay, so that's me subbed in pi over 4. Take away, and I'm going to sub in 0 into everything here. So negative a half. 0 plus 4 is just 4. Cos 2x. X is now 0, so it's cos of 0. Plus sine of 0 over 4. Okay, so you do get a mark for that line, like showing that you're putting in the limits here. Alright, and then if you can get your scientific calculators, just make sure it's set to radians. Hold on, I'm just going to get that. Okay, so make sure it's set to radians, which mine is, and then you're just going to type everything into your calculator pretty much. So I'm just going to type this first part into my calculator. You guys can do the same. Okay, so that first part there, I just got 0, that first part, plus, I'm going to type this part into my calculator. You could do it all in one order though. So sine 2 pi over 4 it gives you a quarter. Take away, just going to type this part in. that first part, just gives you -2 plus, and I know that sign of 0 is just 0 as well. Alright, so we simplify this. 0 add a quarter, just a quarter. Minus minus is a plus. And that just gives you 9/4 for that one. Okay, so pretty much the exact same as what we've done. I'm just going to scroll back up to the top here so you can see the question. The only difference here is that your limits. Okay, so please do everything the exact same. Do your full integration by parts and then deal with the limits at the end. That's the only difference. Alright, make sure you've got a copy of that. Feel free to go back and look at the video again. Make sure you understand everything. Okay, once you've done that, can you please go to page 57? This should be the Unit 2 booklet in your wee Scholar books, and it's questions 27 through to 35. Okay, remember there are answers at the back of the book, and if you're struggling at anything, please let me know. Just leave a comment on the post, and then I'm more than happy to go make a video like this and go through the question in full details. Alright.